Hey everyone, and welcome back to another simple science and technology video. And in this video, we look at what cloud computing is all about, what it's trying to achieve, what it's trying to replace, with a simple and great beginner-friendly demonstration of creating and operating a website. Imagine you've just launched a brand new internet business called Simple Science, a global e-learning platform. You've got your million-dollar idea, some friends, and now you need to launch a website. So what do? You first need to think about what you need for your website. So a beautiful user interface or a front end with some web pages such as a home page, a course page, and a purchase page would be a great start. Now, in order for your website, by the way, is simply a bunch of files, more specifically a HTML file for each web page that includes a bit of CSS and JavaScript code. For that to appear in your customer's browser and be accessible over the internet using simplescience.com, you need to generate these HTML files using some sort of machine which can then transmit the HTML files over the internet to the customers on their web browsers. So these machines that generate and send the pages to your customers are known as a server or a web server. So fundamentally, to provide web pages for your customers to see, you need some sort of machine to do this. So you need at least a front-end web server. You may also need what is called a backend or a database where you can store data such as your users or your site's data, which may run on some sort of database management application like those provided by Oracle, which are again a bunch of code. So you need another machine to run that database application and store the users or content database and provide the data to your web server. So you will need to now somehow find two physical computers or servers to run your front and back end code. And this is the approach that traditionally was taken, where you literally go and buy two physical computers or servers and place them in your startup office. You need to supply it with what it requires, which is electricity, some cooling, some sort of basic networking, and an internet connection, of course, and some office space. And with these requirements in place, ideally you can run your front end and back end code. So now with your website online, it is reachable by your customers. Okay, congratulations. So here's a very simplified image of what this infrastructure could look like with your two front end and back end servers and the simple network infrastructure. You're connecting things into wall sockets and wall ports. Okay, so a simple infrastructure with this diagram should look like this, where you literally got two servers, and depending on their specs, so how strong the CPU is as well as the RAM, the disk space, it's able to serve up to a number of users at once. Okay, so let's say it's able to serve 100 users at once. And now I'm going to introduce a simple concept of server utilization, which basically shows you how much of the computing power from the CPU, RAM, GPU, and disk you're able to use to serve the web content. So a good number would be like 50% that is good to maintain. Now with your new success, more users and more customers start to visit your website. So the traffic increases from your website to 100, from 100 to 200. Now this causes your CPU and RAM on both servers to work harder to deliver the information and web pages to your customers. Now soon as exam season starts to come about, the number of users, 300, will start to appear and visit your website, and at once you notice that your CPU and RAM will start to reach its maximum capacity of about 100%. Okay, so it's now about 90%. Now if it hits 400 users, you will of course have servers that are overworking. Now in order to overcome this, traditionally what happens is people will buy another set of web or database servers from a technology provider, like how you'd buy a new laptop, okay, to share the load, naturally allowing the utilization to fall from 90% earlier to 50% now. Now exam season finally hits. Now you start to experience huge surges in traffic, prompting you to have to buy more and more servers. So it seems like business is surging. You're getting more traffic. You're able to scale out by buying more and more servers from the provider. Okay, now inside your new office basement, which you've just rented out, you now have 12 pairs of front and back end servers. So you're looking forward to scale to a medium to enterprise level sort of data center with these servers. So you need more office space to meet the exploding student demand. So with a larger number of servers, you're expecting your data center or your server room to look more like this. And again, back to our simplified infrastructure, you can see that the number of servers are scaling out, but the aim is to maintain a desired utilization amount of about 50%. Okay, so we're scaling out, but that's the basis that we're going to scale out by. But then, of course, exam season doesn't last forever. Okay, so obviously the day after the exam finishes, traffic begins to fall as more and more students complete their exams for the year. So as expected, the number of users may fall from 5,000 to now only 2,000. And similarly, the average utilization across the 12 servers will also fall. So before you know it, on the week after the exam, the traffic falls steeply to only 500 users, and your servers are plunging in utilization levels. Now, to maintain during the summer, instead of having 12 servers running at an average of 10% utilization, you may be turning off 7 of the servers such that you only now have 5 servers running at all 50% each. Okay, so you're maintaining this 50%, but you're having to turn off servers. Now this causes a particular problem whereby you now have inactive servers to manage, and you've only got 5 out of your 12 pairs of servers. Now this is one of the big problems with in-house or on-premise server management. Okay, so the thing is, with inactive servers, once you've used them, they're very, very difficult to sell. You've also depreciated in value, one of the causes of it being difficult to sell. Of course, they are hardware and they take up office space. They're inactive, you can't use them for production. And of course, you've got the associated overhead costs that we mentioned before that needs to be taken into account. And that's not including data center management staff as well. So essentially, you're looking for an alternative, some sort of ideal technology that allows you to achieve virtually the same thing. A virtual server that can be deprovisioned and provisioned within minutes. You can get a server instantly and you can get rid of that server instantly and not have to worry about capacity management. Also, ideally, you don't want to have to worry about overhead management as well, because once you do scale out, when traffic surges, you won't have to worry about the additional electricity, cooling infrastructure, the networking infrastructure. When it does shrink, you don't have to worry about detangling and basically deprovisioning those as well, right? So what we're trying to achieve with some sort of virtual server is basically the same infrastructure as you would achieve with a physical server. Okay, now what you are trying to do is to address the difficulties that are faced with physical servers of it being difficult to sell, difficult to scale, depreciating in value, taking up office space, as well as the associated overhead costs. And this is where cloud resources known as virtual machines comes into play. Okay, virtual machines are accessible over the internet, so you do not have to reach out and go literally buy a massive server into your office to operate. They are not physical resources which you have to manage, so there is no overhead management. The networking, the cooling, the electricity is all managed by your cloud service provider in their remote data center somewhere, and you just basically access their resources. Virtual machines can be provisioned and deprovisioned in minutes, and I'll show you how that is done later. And the three, and it's not limited to these three, cloud service providers that are famous for providing virtual servers and virtual machines are AWS, Azure, and Google Cloud Platform. And they have different names for effectively the same thing. And the way in which you can provision or get access to these resources is very, very, very simple. You simply need to log on and create an account, log on after creating an account on their respective platforms or consoles or portals. And access is either virtual machines or EC2 or Google Compute Engine. and you can create a new virtual machine by clicking add. And once you specify it and it goes through the initialization processes, you can hit stop and delete whenever you need to turn off that particular machine. And effectively, that gives you an entire server as you would have with a physical server, but you access this server over the internet. Okay, so this really shows you the dimensional difference between managing cloud resources, which is done over the internet on some sort of portal or using a software development kit on a command line, which I'll show you another time, compared to managing a physical infrastructure just to launch a website. Okay, so this is a huge revolution in the way in which we can interact with computing resources. So essentially, once you provision a resource like a virtual server or a virtual machine for either your front or backend server, you can configure this virtual server as you would with a physical server previously, such as installing an operating system, adding your web or application code, setting up the networking and upgrading anything like RAM or CPU disk space if you need to, but only better, you don't have to worry about managing all of those overhead of what we mentioned earlier. Now, the fact that you can request or provision your servers within minutes and terminate them and shut down just as quickly explains why public cloud resources like virtual machines support an on-demand service model, which makes your business more agile to changes in demand. So what I mean is, cloud resources, you only get billed for the time in which your servers were on or used. So this is what we also call the pay-as-you-go model, where you're paying for what you use. So cloud resources are primarily consumption-based. For instance, you're only charged for the usage of a particular machine per hour or per request. So how much you are charged for running that server is basically a multiplication of the hourly rate of that particular machine type. Okay, so machine types have different vCPUs, have different memory amounts, and different storages by the time that it was on. Okay, and now onto the topic of turning on and off your servers to meet demand appropriately. Cloud service providers have realized that this is actually quite manual, of going onto the platform or scripting some command line script. And for many years, they have supported a feature known as auto-scaling, okay? And which allows for your machines to scale in or out and replicate when they're being overworked. And here's how it works. So say, for instance, your website, our Simple Science website, currently receives low traffic with only 3 front-end servers receiving the requests, okay? Now, what happens if high traffic starts to appear? Of course, the server utilization will start to increase. Now, of course, it's starting to reach the maximum threshold at 90%. So what do? You can manually add more cloud resources by clicking on the console or whatever, or you can do this. You can assign it to an auto-scaling group. And an auto-scaling group uses an auto-scaling rule, which specifies, based on the server utilization, if it exceeds a certain amount, add a new VM. So our auto-scaling rule here is whenever a server exceeds 70% in utilization, add an additional VM. So in this particular high traffic scenario, the utilization is 90%. So it obeys our rule. So what do? It automatically adds more cloud servers, okay, such that the rule is not obeyed anymore. Okay, so now the average server utilization is only 50%. Okay, so it won't auto scale any further. Now, what happens when traffic decreases? So when there is low traffic, it detects the fact that the average server utilization is now less at only 20%, and it sort of inverses the rule whereby you don't need that many servers. It doesn't obey this rule anymore, so it automatically shrinks your auto-scaling group and reduces the number of servers that you need. So this is the same thing pretty much as manually scaling up and down, but you're basically automating this process with an auto-scaler. In reality, what also happens is you add an additional load balancer in front of your auto-scaling group, And this particular feature ensures that the load, the traffic, the requests that comes from your users are distributed evenly between all the servers that are available in your auto-scaling group to ensure that no servers are being overworked or being underworked, okay? And this ability to auto-scale enables one of the huge benefits of cloud, and that's elasticity, or automated elasticity, which basically allows your infrastructure to automatically scale in and out based on demand. So when there's low traffic, you can have less virtual machines available by way of automation, or when there's large traffic, you can infinitely scale. So it's like a rubber band that really can infinitely scale based on traffic requests or rules that you do specify. Okay? Now, on-demand, scalability, elasticity are just a few of the major benefits of using cloud resources. Similarly, virtualized servers, such as this compute engine service by Google Cloud Platform, is just one of the plethora of virtualized computing resources that are available in public cloud offerings. You've also got things like storage, cloud storage, or in AWS it's called S3, which is a cheap and infinitely scalable solution for storing objects and files. So suppose you need a solution to store the thousands of gigabytes of images and files that you may need to share to your students. You'll definitely benefit from a solution like this. Now remember how I mentioned the backend servers that you may need as your database. Public cloud providers now provide fully managed or partially managed database servers such as RDS from AWS or Cloud SQL from GCP, which literally everything from the database runtime software has been pre-installed and will be patched and managed for you throughout your usage, and all you need to do is connect your whatever front-end servers to the database servers from Cloud SQL, and now you pretty much have the bulk of your infrastructure sorted. Even the domain name hosting service is managed by public cloud servers, so you can manage what URL you would like your website to have right on the cloud, and you can attach it right into your networking infrastructure. Now, a very important and often underrated perk of using services from cloud providers is the availability of tools that can allow you to connect to your on-premise or physical IT resources that you may have in your office or data center or your server room to form what is known as a hybrid cloud environment. So things like interconnect, okay? So it allows you to incorporate both internal on-premise resources and cloud-based resources using tools like Cloud VPN, Cloud Router, API gateways, interconnect offerings that essentially help you connect internal resources, okay, on the right, with cloud-based resources on the left, as if it were one connected internal infrastructure. Now in this video, with our simplified example, we barely skim the surface on the enormous amount of benefits that using or moving public cloud resources can bring to your company, whether and especially if you're part of a startup or you're a cog of an enterprise machine. In other videos, I will dive much deeper into cloud concepts such as the myriad of services and products that cloud service providers may offer, the difference between infrastructure classes like IaaS, PaaS, and SaaS, and keeping you up to date with the latest trends in cloud and technology. For now, thanks for watching my video, and please like and subscribe if you found this video useful.